The project's piling up? What's going on? Everybody looks a little more tired than last time.
Midterms next week.
Ah, I see. I see. All right. Well, you don't have a midterm in this class, so that's nice. I am kind of curious. Let's see. Anybody go see the comet? You guys already saw it.
I tried, but it was cloudy.
Clouds are the worst. Yeah. All right. I think you still have a couple more days if you want to. It's kind of cool. Got to wait 80,000 years to see it again. So, what about? Let's just get some of these attendance points knocked out. Y'all can volunteer, or I'll just call on you. But I'm curious if anybody had thoughts. We had a fairly lively conversation last class. Got kind of cut off in the middle of moons, but we finished up climate. We talked about calendars a bit. What are your thoughts? I want to hear from you guys. So yeah, I read you guys a bit of this David Graeber book called The Dawn of Everything, which I highly recommend. It's really bizarre. We did have a conversation about it on my podcast this week. We just put it out today, and it's funny because it pisses off a lot of people. And I'm trying to understand why exactly. And somebody sent me like 6 different critiques from the Wall Street Journal to everybody else about this book, like why they were pissed off about it. But it seems like the critique is something, well, so David Graeber's position, just to remind you guys, is something like this narrative that we get in 8th grade that society goes from these kind of primitive hunter-gatherers, and then it finally gets its act together. I was trying to figure out how to phrase that properly. Try to get their act together, and they finally become a civilization once they have agriculture. But then agriculture leads to hierarchies, and we get social inequality, and it sucks. And so David Graeber's position in this book is essentially that that's not true, and the archaeological record doesn't prove that out. It's actually something more like different indigenous people had lots of different ways of living. They weren't stupid. They hadn't not discovered civilization. They just didn't want it. And that's a really radical perspective that seems to make people angry for some reason. And I was surprised that it made people angry because it seems like at least an interesting position. There are of course plenty of examples of tribal groups that do live in very egalitarian ways that are, that go along with that narrative, but there's also other stuff going on. So yeah, Stonehenge is really, it's a really good example of a group that seems to have gotten together, organized massive megalithic structures, that they didn't have agriculture, and then half the year they just disbanded into these herder groups. And actually, I was reading more about Göbekli Tepe, and it seems to be a very similar situation. They also didn't have agriculture, and yet they somehow came together to put together these massive megalithic structures, which, it's not impossible to put a megalithic structure. You don't need, spaceships or anything, but it does require some coordinated effort and people agreeing to work together in some sort of social cohesion, maybe a temporary hierarchy of some sort. So, I don't know. There's something really fascinating. I'm going to keep tearing that book apart. I'll bring some pieces in as I discover them as we go. Thoughts, anybody on that? Yeah? All right, no thoughts? Think about it. Think about it. Think about it the next time somebody says, and then we had civilization. Right? It's so funny. You guys, yeah, everybody does it. Anyways, we'll get more into that later. Let me call on somebody, so I still got to fill out this second round.
I guess I've never really thought that CO2 was that small of the atmosphere. I was just kind of like, yeah, it's up there.
Yeah, it's an interesting one. It's funny because when I ask that question every time I teach this class, and I get everything from 25% to 60%. And so 0.04% is always kind of shocking to people. Not to say that it's not a factor in all of this, but there's a lot of stuff to pay attention to, and I hope that's what came across. I did want to point out too, and I may as well just put this out while we're talking about it. We actually had 2 really, so this, the climate's such a complicated endeavor, and I had 2 really good conversations on the podcast. If anybody's interested in this stuff, I would recommend both of these. This guy is the director of NASA's Goddard Space Science Institute. He's also the climate guru for the state, let's say. So he's a staunch defender of, let's say, the mainstream climate narrative. This guy is a Harvard and MIT professor who is very concerned about this fixation on CO2 at the expense of everything else. They kind of hate each other, and it's like a really interesting two sides of this argument. So if you guys want to go deeper on that, that's episode 194 and 183. Really interesting conversations with those guys. I think we've had both of them on more than once, too, at this point. But those are a good place to start. Thoughts? Anybody?
Do they hate each other? Like they got beat?
I mean, they just talk a lot of smack about each other. Yeah. Yeah, it's really interesting just how polarizing this stuff is. I mean, it's really hard for you guys to understand, but scientists are really vicious with each other. It's one of those things where the only capital they have is their theories and their reputations, and so being right is really important, which is unfortunate because science is all about possibilities at the end of the day. They're called theories, not realities, right? So, yeah.
I guess this is something I've been struggling with too when doing a little bit of research on about different topics, but like differentiating like science discoveries versus conspiracy.
Yeah, it's horrible.
It's just something that I've struggled with.
Yeah, I struggle with it too.
So many different types of evidence that.
Yeah, I think that's why it's really smart. Like one thing I try to do, like the whole goal of my podcast is to get people with different ideas. So people who have completely different takes on it. And kind of, instead of me sitting there, when I first started the show, it was largely me calling up physicists and picking on them because I thought that their ideas were kind of, outlandish, right? And we'll talk more about some of that stuff as we go through it. But I found that it's actually more interesting just to get people with completely different ideas, not really like judge their ideas, but just ask them questions and kind of let them hang themselves if they have bad ideas. But when it comes to sorting out, I really hate that word conspiracy theory, to be honest with you. I'd be curious what you guys think about it too in general, but it kind of implies that it kind of implies that, well, first of all, there have been plenty of real conspiracies. So a conspiracy, what does that mean? It's like a group of people have conspired, have gotten together, and made some sort of shadowy move that has resulted in X, Y, or Z phenomena. Whether it's like the overthrow of a government or whatever else. Okay, that happens all the time, first of all, that we know about. And that doesn't even get into the things that we don't know about. The problem is, since the advent of the internet, of course, anybody can go online and stitch together some images and call it evidence to support their theory and so on and so forth. And so, all you can really do is use that as an opportunity to try to follow up on some of that stuff, get other people's perspectives, go into Stack Exchange, go into Reddit, see what people think about it, see what other papers support or don't support it. But with something like climate, it's a real nightmare because you're trying to talk about a phenomenon that takes place over hundreds of thousands of years usually, and it's not direct evidence. You have to make these second, third order estimates, right? Like we were talking about, how do you estimate temperature from 10,000 years ago? Well, it's not easy. Turns out you're looking at evaporation rates of oxygen isotopes in snow. And it's like, is that a pretty good readout? Probably. It seems reasonable, but it's also like, how accurate can that be? I didn't have time to show you guys a map of the hundreds of millions of years of climate record, but it's kind of nuts. Basically, you look back and first of all, it was very much warmer in the past, like in the dinosaurs. But the noise on that graph just gets out of control the further you go back. It just looks like a noisy mess at some point. So it's very difficult. And of course, it becomes very emotional for people, right? Because any time that people are sort of questioning the official state narrative, it's often assumed that they're somehow against the environment or something. And that's really tragic too. And it doesn't just happen in climate, it happens in almost every debate. So I think anything you can do to really just ask questions in these situations, if you have an opportunity, it's a lot more fun with, even if it's like a flat earther or something that you know is ridiculous, it's kind of more fun to just ask questions than it is to try and shoot them down. Usually, like I said, people usually hang themselves if you give them enough rope. Or they have a cool idea, and maybe you can fit it into your worldview. So, what do you guys think? You got some, anybody, I don't know. Thoughts? Anybody? Yes, please.
As moderators, like knowing that each of them knows that the other person is already there sharing their opinions, like, do you kind of have to play like, yes, I agree with you, like,
No.
are they, well, in general, are they kind of like respectful of you seeing both their sides?
No, not at all. No. It's really, I recommend you guys watch just 5 minutes of either one of these just to see the tenor of the debate. It's extraordinarily vicious. And it's just each one of them presenting, right? We didn't have them both on because, according to each one of them, there's no point in talking to the other one. Which is really funny because they're both like some of the most esteemed scientists in their field that have ever existed. So just to completely write the other off is pretty preposterous, actually. Gavin's definitely more of a public figure. Like I said, he's kind of the state mouthpiece a little bit. There's this attitude, often you see this too amongst state mouthpiece type people with science in general, like Bill Nye or Neil deGrasse Tyson or something. They kind of believe that like bending the truth a little bit in the name of what's the good is the right thing to do. That's an ethical consideration for you guys to all ponder in general. Like, is the truth sacred, or is it better to, let's say, distort the truth in the name of something more progressive? Please.
I was just going back to your earlier. I think that's kind of a cynical way to look at discovery.
Which piece?
Just like if you give someone enough rope, they'll hang themselves. It's almost like you're expecting them to fail.
It is. I was talking about bad ideas and conspiracy theories. Yeah. The alternative is if you give somebody enough rope, they might build themselves a sail too, right? If it's a great idea. That happens more often than not. I'd say, so very quickly once I started this podcast, my wife and I do it together, and we realized that we had to meet with people for a while before we even filmed the thing. Because we too many times went into these conversations and their theories were so unconvincing that it wasn't worth actually releasing, so we were wasting all this time recording things that we never released. So usually, like, by the time I'm interviewing somebody, I'm already interested in their ideas. I think that there's some needle in the hay there, even with wild ideas. And I've had some really crazy ones, but there's still something really interesting about them. I had this one guy who had essentially gone through all the NASA records and reconstructed the velocity data of the planets and had constructed this simulator that was as nice as the one you guys used in the lab section. And he had redone the solar system such that there were, basically there was 2 orbital points in the solar system, and all of the planets, including the sun, orbited these 2 planets. And he was completely convinced that we lived in this geoaxial binary system of a solar system. And I didn't really buy it. I still don't really buy it. But the fact that he had been able to do all of these mathematical transformations and make a model that was just as predictive and reliable as the standard simulators and so forth was fascinating to me. And it turns out that it's really a matter of deconstructive analysis. So just the same way that the Ptolemaic model we talked about with the Earth at the center and all these epicycles, it was very predictive, right? The mathematics worked. So I found that piece of the puzzle was interesting enough to have that guy on. Now, I didn't buy his model for other reasons, primarily because I don't think that NASA has made up everything that they've ever done. And his model kind of falls apart when you start asking questions about the relative mass of the planets and so forth. So in that case, it's an interesting thing. I also think that he looked pretty bad when he just denies that we've ever measured the mass of a planet or something like that. It just kind of falls apart. So that's what I mean. And then, of course, many times you ask people questions over and over again, you give them a lot of rope, and they sail away with it, and it's awesome. That's more the case. I didn't mean to deride how one should, conduct a conversation with somebody with an idea in general. I guess what I'm more trying to point out is that I don't feel like it's my job to just necessarily tell someone why they're wrong about something. That usually just ends the conversation. Although it has happened, and it's kind of unfun. Thoughts? Okay. All right, let's see who else here. How about Luke? Are you here? No. How about Levin? Okay. Yes, we talked a bit last time. Yeah, you had some interesting pushback last time. I actually didn't. You asked me about the acceleration of it in recent times too. What I didn't get a chance to ask you your own thoughts about that.
Well, I'm not sure because I feel like I don't know enough about it.
Yeah, fair enough.
Go on with it
Yeah. It is interesting. I mean, the fact that the climate changes is something we got to get ready for, at least in one way or the other. It certainly seems like if we follow those trends out, that we're going to be in for another ice age at some point here. That'll be interesting, right? But yeah, there's more questions than answers with that stuff. It's tricky. That's why it's important to listen to people's different perspectives. Try to piece it together. How about Sophia? Yes, you already piped up. Do you have any more thoughts?
I couldn't get my mind off of the train conversation that we had.
The train, remind me.
About how it would be a lot easier if we ran a train.
Ah, yeah, yeah,
I'm from California.
yeah,
And my hometown is unincorporated, but we have a BART station now.
yes.
Like Bay Area.
Yeah, I know the BART very well, yeah.
And it's just a really strange parallel to be like, I'm an hour away from San Francisco, but we have 2 stoplights in my hometown and gravel roads.
Yeah, that's wild. What town is it?
Nixon, California.
I don't know that, yeah. Is it a new BART station? They just added it?
We're like 20 minutes away from my house.
Okay, okay.
Yeah.
Yeah, the BART's super convenient, depending on where you live, especially. Yeah, I don't know. It's bizarre. It's very bizarre. I think the Europeans would think we're complete morons. It's very difficult to track this back. I think that speaking of conspiracies, I think that there's been a really strong push, especially in the 50s, for the automotive industry to build these freeways. And I've tried to get to the bottom of that before, and it's another one of those rabbit holes, right, where everybody has a perspective. You got a thought?
Yeah, I mean, with the whole, like, I guess freeways and like traffic, I've gone down my own rabbit hole with like what other countries require for people to get their driver's license. It's just astronomical. It's actually a privilege over in certain parts of Europe, whereas in America, you just take a driving course when you're 16 and you're just given the keys.
Yeah, not to mention gas prices, right?
Yeah.
Yeah, I think most people just can't afford to drive in a place like England, right? I don't know what the equivalent is. I visited England when I was like 15 or 16, and I think it was less than $1 for gas here at the time when I was first learning how to drive, and it was almost $10 there at the time. So who can drive, really? Certainly not teenagers.
That's like meant for, I guess, like a certain class of people.
Yeah.
But in a sense, that opens up avenues for trains and
Yeah.
public transportation.
They're really fun too. Like I took a train when I did grad school, in New York City, and I lived in Queens, and my school was up on the Upper West Side, which is an hour train ride basically. I had to switch over at Times Square every time, but it was really fun because I got to read books for 2 hours a day basically, which I honestly I do now, but for many years after that, I didn't have time really to. I mean, I'm not talking about like science books either. Like I was just reading sci-fi and fun books too, listening to music. It's a really fun way to commute by train compared to driving where you're just like out of my way, It's so convenient. Yeah, it's really wonderful, and so much walking too. When I lived in New York City, you hardly need a gym membership or anything because you're just moving so much. So yeah, I mean, I'm glad you guys care about that. That's something I could actually see getting fixed. I think it won't happen easy, and people are gonna have to fight for it. Yeah.
Well, so I really like the train idea. I think it would also have to be done with a better bus system as well.
Of course.
Like, the train would be on the freeway, but
Yeah.
you'd have to get people to the train.
True.
If you're not having like a vehicle to drive there. So, and I know I've been to Europe and it was like it's like buses. Like every third vehicle you see on the street is a bus.
Yeah.
And so
So cool.
yeah, it's
Yeah.
awesome. And
Sometimes they have like light rail too. Like in San
Yeah.
Francisco, there's light rail, and so you get a pass. Like I had a pass when I lived in San Francisco, and you could just use it on the BART, and then transfers over, and you can use it on the Muni system, which is the light rail and buses and stuff like that. You can take your bike on the Muni too. Take your bike on the BART. I mean, come on, it's like a no-brainer. Which is funny that everybody kind of agrees, but it's just so difficult to put into place.
I guess just another thing, like the whole, I guess public transportation and like also getting your license, like specifically with Germany, we need to like take, I think, like a year or 6 months of driving theory.
Whoa,
Or
it's 8,000 euros.
Like 3,000.
Oh, 3,000 euros. Good
Yeah.
lord.
like you have to take a class on like driving theory on like how, like the proper way to drive.
Yeah, interesting. Like driving etiquette.
Yeah,
Uh,
exactly.
That's
Exactly.
funny. Like missed manners for driving or something.
Road rage we all have.
Yeah. I do think that it's kind of I used to like going on road trips when I was a kid a lot, but the older I get, the less patience I have for it. I don't know if things have changed or if I've changed or what, but I just find it to be kind of miserable, and people are so grouchy on the road and everything. Yeah, I would love to try. I mean, and planes are not fun for me either. Probably because I've studied too many airline disasters. But but seriously, the airport, it wastes a whole day of your vacation. I like the traveling by land a lot. It seems you can see the countryside, you can visit the different places you go to. So yeah, I mean, that'd be really cool if your generation can pick up the pieces with that. It seems like we have the basic land, corridors open already. It's like it wouldn't be that hard physically. It's just a matter of people raising their voices loud enough, I think, and making it happen.
I think this kind of connects to talking about science and everything. I didn't realize how political it was to talk about public transportation.
Oh, oh, interesting.
Because I mean, when they put the train station when I was like 17, so I was like, oh my god, I can do this up in an hour and a half for like $20. And I'm like, oh, this is communism.
Oh no,
Yeah.
interesting.
Everyone's lost their minds about it.
Well, I'm skeptical of that kind of argument too, because I know that in San Francisco there's some weird stuff with that. And in general, like there's different neighborhoods they don't really want to give access to San Francisco because they consider them, sort of dangerous neighborhoods, right? They don't really want those people. So they shut down the BART lines at like midnight in San Francisco, which makes it very difficult if you go to a bar or something, right? I play a lot of music, so we're always playing shows. Like you can't really take BART to do these things because you'll never make it to the BART station in time. So there are weird little political limitations on it. Please, yeah.
I grew up in Seattle, and we just got the light rail to a little farther north of Washington. And it was a big political thing of like our taxes being raised, and people who lived up north in like Snohomish County area that hated the light rail being there. And as like someone who lived
Because of the money costs or
because
what?
of the money costs, because of well, just like they don't want the Seattle degenerates.
There's that. I think that's more of it,
It's
yeah.
like the big thing. Yeah, for sure.
Yeah,
I grew up around Portland.
okay.
They have like the TriMet system.
Mm-hmm, that's right. I lived there a bit.
Yeah, you can go from like Hillsborough to Milwaukee down to Clackamas, and I've used it and it's pretty damn convenient. I think the only problem would probably just be like the homeless issue.
Mm.
But yeah, it's
Yeah, they had some sketchy stuff on those when I was there.
Yeah,
It was like people stabbing each other and stuff.
Yeah, they were.
I was like, what is going on? It also seemed really slow compared to the other cities I'd lived in. I would look at these commutes, it's like a 20-minute drive, and it would be like a 2-hour, you have to change trains a bunch, and I don't know.
Like there's like multiple stops, and so it's
Yeah,
it's a
I don't
little
know.
weird, but like hearing everybody talk, it's just like kind of crazy because I grew up in the area.
Because you were used to it, right?
Yeah, kind of. And then even then, you could take the TriMets to somewhere far, and then they'll have the TriMet buses.
Mm-mm.
So it's like an
Yeah,
extension.
it's so logical in some sense. I mean, there's ways it can go sideways for sure, and there's definitely levels at which it's implemented productively. Yes, this is cool. You guys care a lot about something. Heck yeah. All of you guys, let's hear from you.
Was the thing that started the conversation high-speed rail?
Yes.
Yeah. So I'm from Fresno, like right in the heart where that's all happening. And
Mm.
everyone's like, oh yeah, we did network and construction of the high-speed rail. I'm like, do you? Because I feel like they've been working on that for years.
Yeah. Well, that's the NIMBY problem, right? That's nobody wants it going through their backyard, basically.
Right. No, but I see the construction over, like right now at least, but it looks like it's been sitting there, like no one working on it for years. But see like the beginnings of it, like on the side of the road. But I remember hearing like my family and everyone talk about it all the time, just talking about how it would just be so much easier if they could build already. Just because I'm like right.
Just get it over with.
Yeah, 'cause I'm right in the heart of it. California.
Yeah.
It's hard for me to go anywhere, do anything.
Yeah. Yeah.
100 miles away.
Yeah. I don't know. There's so many weird considerations. I think a huge part of it is there's definitely populations who don't want people coming into their whatever, right? I know. It's the worst argument, but I think that drives a lot of it. People won't say that on its face, like they'll make monetary arguments, but I think the monetary arguments are always really weak because like we have no problem printing money for bailing out banks and to the tune of trillions of dollars. Like there's plenty of money if we want it. It's like ultimately, what is money? Well, it's like if as long as we believe that it's valuable, then we'll keep using it. And so I'm not totally sold on that being a real restriction.
The big thing I noticed, like there's kind of like a fear of like public transport, like at least here. It's like you think of like New York subways and you're like all the like scary things. At least I have at least. I'm like I was always kind of iffy about it. But then I went kind of like how you went to South Korea, it was like really easy and nice. I went to Japan, it was like the trains were all nice and clean and like very smooth and very easy. I was like, wow, this is so convenient. Like little kids would just go on by themselves and they just go to in there.
Yeah, there's something really interesting. I don't know if you guys heard about this like broken windows policy in New York City that happened. But like New York in the 80s was like the jungle. Like it was like scary, like legitimately scary. But I don't remember who it was, but somebody basically just enacted this policy one day. It was probably the mayor at the time. That what they were going to do was they were going to make that subway system super clean, and every night, no matter how like vandalized it got or whatever, they were going to put people to work cleaning the thing, scraping all the paint off it, whatever they had to do. And like crime just completely fell in the city because they had like a source of pride in this subway system. And like as somebody who rode it every day for 5 years, twice a day for an hour each way, like it's a beautiful subway system. But it wasn't always that way. So it's not as simple as just getting a train system. You got to take care of it too. Up front, yeah.
I'm Shane, and I'm from Colorado, and we have like the best bus system or like public transportation than apparently like anywhere.
Huh.
Like there's buses everywhere.
In Denver area? Denver area?
Denver, Boulder, Longmont, like every. I mean, like the smaller cities. Once you get like. I don't know, even like the smaller cities, most of them have some sort of public transportation, and that's like my entire life.
That's cool.
That was like.
That's really good to hear.
But I kind of have like mixed opinions on them because I do love the public like busing transportation, but there have been a lot of times where I have encountered like violence.
Yeah, it happens.
On a bus.
It happens.
Way more.
Than walking down the street.
Bigger cities and stuff like
Yeah.
that. But like. I could understand a little bit why people kind of are like, but then I don't know. I feel like you could just put in like more regulations.
Yeah, or just put more cops around to actually know what to do.
Yeah.
Yeah. It happens, but I think anytime you get people clustered in a small space together, then if you don't protect against it, you can welcome predation. It's the same anywhere in any ecosystem anywhere on Earth. There's going to be a few bad actors, and you got to get them taken care of very quickly. There's this guy near my house who's just decided that his AR-15 is, the source of fun at 3 a.m. And seriously, and I'm like, this is going on for several nights. And I'm like, really? Like nobody's like calling the cops on this? And so finally, yesterday we're like making dinner, and he's just, I don't even know he has the money. Like those rounds are like $1.50 a pop. He's just ga. And so I just call the police and I'm just like, yo, this is freaking out my wife. I'm sure it's freaking out everybody in the neighborhood. Can you please send somebody over? And he's like, oh yeah, for sure. That was it. It was over after that. It's like, just nip these things in the bud. I think there's no reason to be afraid of any situation. That's literally the reason we have police. It's like, they're really nice. Just talk to them. Anyways.
Yeah, I was just gonna I don't know how good of an idea this is, but I guess I thought of a solution for public transportation. I think a big problem that people have with I guess mainly conservatives, is like the raising of taxes for public transportation for it to be constructed.
Yeah.
I guess maybe a solution was, I mean, America's kind of built on like capitalistic, I guess, foundations.
Sure.
It's been ingrained into American culture for hundreds of years.
Yeah. It's built like a corporation.
Why not privatize the transportation and kind of create a competition to fight for those people to earn their business?
Well, that's what happens. Like, I have a friend who builds these BART lines, actually. I forgot to even mention that. One of my best friends, he works at an engineering firm. It's a private engineering firm. There's so much money that goes into these private firms. In fact, San Francisco has made a rule that it's something crazy. It's like, I want to say like 40 or 50% of the contracts have to go to single shingle firms. So basically like mom and pop shops. And so they're constantly outsourcing all these little pieces. It's a huge boon for the economy. So I don't know. I mean, the monetary system is very impenetrable, and like I suspect that people who use those arguments about there not being enough money are upset about something else. To be honest with you, I don't think that plays out because those same people would probably be happy to take government money if it went to their firm or whatever. So I'm very skeptical of that argument. All right, one more. Then we got to do astronomy. Yes.
Prioritizing public transport couldn't work. There's not enough money to be made. The cars are way more profitable.
Maybe. Unless you're able to bring in lots of private contractors. But yeah, the automotive industry is enormous, for sure. Not to mention the petroleum industry. I mean, almost everything in this classroom is made out of petroleum, for starters, right? It's a huge piece of the economy. So yeah, all these plastics and these desks and your chairs are all made out of petroleum. Everything's made out of petroleum. So yeah, big money there, for sure. And that's a really hard thing to overcome. And I'm not going to even crack the tip of that iceberg because it goes really deep. Sorry, one more hand. Yes, last thought.
The only thing I'll say is like that just like made me like triggered is like all these trains are doing is making us more efficiently contributing to whatever city we're a part of, and like so it is more beneficial for capitalism anyway.
It's true. The problem is there haven't really been any good alternatives to capitalism. So yeah, it's like the worst system that's not as bad as the alternative, something like that. The Nazis get a lot of heat for what happened in World War II. They killed, 6 million people, non-Aryans that they didn't care for. But the Soviets killed like 60 million. So, and the Chinese Maoists maybe killed some estimates as high as 100 million people. It's not clear that there's a real viable alternative, which is why I think it's so important to think about this ancestral knowledge very differently. Because I think the solution is out there. I think there are different ways to organize your society, and they're not just any of these two kind of busted options that we're usually presented with. But I hear you. Like, people end up in cities. Cities are gross. There's nowhere else to go to work. A lot of you will probably end up in cities. A lot of people in cities spend their whole lives trying to figure out how they're going to get back and live in the country. It's very tricky. So, yes.
I have a question about calendars, okay?
Yeah, calendars. Let's do it.
Okay. I might sound like an idiot, okay? So you said last class that there's leap years every 400 years, or only like years divisible by 400.
Yeah.
So there wasn't leap years in the 1900s. Like there was just no leap years.
Let's go back to that 1 second. Because I'm gonna forget how this works if I don't look it up. How did this work? All right. So centuries divisible by 400 were leap years. So centuries.
That's what I meant. Yeah.
Thought we said it wrong at the beginning of class.
Centuries divisible.
Yeah. So it's like the 1600s and now the 2000s. So there wasn't any there wasn't leap years.
There were leap years not on those centuries, but on still every 4 years, there's still leap years.
Oh, not
Or
in the
leap
16th
days.
century. Okay,
Yeah,
I
exactly,
see. 'Cause I
exactly.
was like, if I didn't
Because they're trying to make up for that tiny little
Yes.
fraction.
I see.
Exactly.
That makes complete sense because
It's really confusing.
4 years. mean, that just, okay.
Yeah.
That freaked me out, because I was like, why didn't I know this? Why didn't I know that my parents lived in a time where there wasn't leap years?
No. Nope. That goes all the way back to the Gregorian. Yeah, but it's just for centuries, because centuries are confusing. They just have to make. I think they just have to make up for that tiny quarter of a hundredth that they have. A quarter of a hundred. A quarter of a hundredth that they have to deal with. Yeah, that's extra, because the year is what, 365.2524 or something like that. So that's 0.0024 that they got to deal with. So they deal with it on these centuries, fourth centuries. Yeah. All right, guys, I'm like almost a week behind in this course, so. And it's fine. I think it's totally fine. I really think it's important that we talk about things that matter to you guys. And you're going to get most of this stuff from the textbook. I do want to talk briefly about the moon, and then I want to talk about light, because everything that we're doing in this class has to do with light, and light's one of the most poorly understood pieces of the whole puzzle. So, I was going to show you guys some movies. So the original, this is from 2012. This is a NASA animation of how the moon was formed. And I just want to give you guys a picture of just how quick these things are updating. So the original idea was that, very popular throughout the 80s and 90s, was that the moon formed at the same time as the Earth. And so they're trying to explain how all these asteroids happen while there's all this debris around at the time. One of the biggest problems with this model that people were announcing as it was kind of crumbling was that if you do, like say you look at the moon, you can see asteroids hitting the moon periodically. It does happen. But if you try to make a clock out of that, so you say, okay, we see an asteroid hit the moon every, I don't know, couple of years or something like that. Then you try to make a dating of the moon based on that, the moon ends up being like 1 trillion years old. And so they were trying to figure out how in the world this could work out. And they try to come up, they have this theory that there was just a bunch of hits at the beginning, followed by another period of bombardment, and they come up with this whole cycle for it. Then they go and get samples from the moon, and they start to consider that, the moon and the Earth are kind of have very similar stuff. Maybe they're made out of the same thing themselves. But and so this model comes out maybe 10 years ago, this one, where there was actually another planet in the solar system that crashed into the moon, or crashed into the Earth, the primordial Earth, which we'll see here in a second. This is wham. Is this it? Or am I on the wrong slide? Good. Sorry, guys. Sorry, folks. Bear with me. Is the same video? New video. Okay, good. Primordial Earth, primordial planets. Primordial planet slams into the Earth, and you get the moon. Hold on, let's see it. And wait for it. Come on. Well, boom. All right, great. And, some piece of it becomes the moon. Some piece of it stays the Earth. It becomes this new version of the Earth. So this is the one that people normally go to right now. There's problems with this one, though, too. So I doubt this is going to be the last theory of the moon's creation. The moon rocks show that the Earth has similar composition. There's problems with this, though. Like, the moon's got a really low density. It doesn't seem to have a lot of iron. The Earth is like a huge percentage iron. That's pretty bizarre. Like, if I showed you a simulation of this, basically what it looks like is that the Theia planet crashes into the Earth, and it kind of liquefies the entire Earth, which then plops off this other blob on the other side that's supposed to become the moon, which doesn't make a lot of sense for why it would not have this same iron-rich core that the Earth does. There's also no evidence of this magma ocean on Earth that should have appeared at this 3.8 billion year mark at the same time. That's kind of weird, too. So all this to say that we probably don't know how the moon formed. It's also very difficult to stabilize an orbit once you have this kind of an impact. That's also almost impossible to imagine. So It's really fun. You can go down the rabbit hole on Stack Exchange reading about people arguing about the origin of the moon. I don't want to say no one knows. Maybe somebody has the right idea, but the truth is probably somewhere in between there. You know, it's also possible, another thing that I really like to play with. So we think that the moon, like I say, we think that it's 3.8 billion years. Why do we think it's 3.8 billion years old? Anybody? Yeah? Why do we think that? We think that it's maybe 4 something, but why do we think that? Yes? Very close, yeah. So they do this radiometric dating, which is similar to carbon dating. It's a kind of radiometric dating. What they do is they look for, all right, basically have this really nice clock system for dating things, which is you look at some ratio of decayed, so radioactive elements will decay naturally, right? And they decay very predictably with this nice logarithmic decay function. So if you have like some uranium, you can basically predict how much of it's going to be around 10,000 years from now. Really accurately, it turns out. So they look at these rocks and they say, what percentage of the original radioactive stuff is there compared to the decay product? And they come up with a date for it. This is beautiful. However, the assumption is that what you're measuring ultimately is the last time that rock was melted. Because the last time that rock was melted was the last time you included fresh radioactive stuff in it. There's radioactive stuff out in outer space all over the place. So what you're really saying is the last time that this rock was melted was however many billions of years ago, and that this is the oldest rock that we've found on Earth. So there's a couple of rocks that we've found. There's literally 2 of them from what I understand. There's one in Australia, there's one in Greenland that are close to this 4 billion year time period, right? Are those from the formation of the Earth, or are those just from a really long time ago when they melted because they got hit by something, or God knows what else happened? We don't know. So one of the reasons when I talk to astrophysicists, geologists about this, they'll say, well, given the Big Bang occurred 14 billion years ago, there's no way that the Earth could be that much older than 4 billion years because it would have taken that long for all the galaxies to form and all of this. The Big Bang is on the ropes right now is the thing, at least the dating of the Big Bang. So all of this theory we'll deal with this next semester, the Big Bang in general. But let's say that it was substantiated by 2 lines of evidence, primarily, which is the cosmic microwave background radiation, along with some ideas about the redshift, and we can deal with that next semester. But when they built this brand new telescope called the James Webb, and they started looking back in time, so they looked at as far as you could, which is presumably, if it's something that's 14 billion light years away, you're looking at the first moments of the universe, if it started 14 billion years ago. Problem is they found fully formed galaxies very close to that date, within a couple 100 million years of that, which made no sense. So now there's headlines coming out. We had a guy on the podcast, this professor from Ottawa, a cosmologist, who's recalculated things in such a way that he puts the Big Bang at 26 billion years. Okay, so they move it back, and I suspect it will be moved back by mainstream cosmologists soon, if not already kind of coming into acceptance that maybe that date was wrong. Well, maybe they keep moving it back every time they build a telescope. So, yeah. I don't totally have time to explain that to you right now. Please take the class next semester and I'll tell you the whole story. It's a very elaborate story and we have to understand some things in order to make sense of it. But they had this idea for most of the 20th century that it was 14 billion years. That 14 billion year date, as far as I can tell, is receding, so it's becoming longer. I don't know that there's a limit on how long it will become based on how good our telescopes get. If we keep making better and better telescopes, and now we can see 26 million years, and we still see fully formed galaxies 26 billion years, okay, now we have to move it back some more. My point in telling you this is that I feel like the more that we extend our horizon about how old this place is, the more time there is for weird stuff to happen. and the older that we're going to be willing to entertain that some of these bodies in our solar system are, including the moon, right? So, you know, and this is definitely getting into like fringe territory here. I think most mainstream astronomers would stick by this 4 billion year old date because that's the oldest evidence they have. That's the point that they can say, we know that it's at least this old, right? Could it be much older? Maybe. Could it be really, really old? Maybe. You know, it's worth pointing out that prior to about 1926, most astronomers thought that the universe was eternal, okay? So they didn't actually have this Big Bang idea at all. In fact, they thought it was a very religious, superstitious idea. It wasn't until the Hubble relationship became a thing. I might tell that story next semester, but let's say that they saw some reddening of distant galaxies. They assumed that it was a recession velocity. We'll talk about all that later. So anyways, this idea of there even being a beginning in a scientific sense is a pretty new idea. And it's, in some sense, on the ropes itself. At least the dating of it is on the ropes. It's interesting when you know, a lot of people on its face have a difficult idea with the universe not having a beginning. Like, can you guys hold that in your mind? Is that troubling to you? Does your mind need to have a beginning for this existence? Yeah?
How would it not have the beginning? I don't. What?
You can't do it?
Yeah.
Yeah.
How they're gonna be good at this kind of stuff.
Yes. Yes. Yeah, it's horrible. Either way is horrible. Go ahead.
I feel like that's very much like, especially, oh my gosh, I do not want to open up this can of worms.
Yeah?
I'm only going to say this in terms of like, thinking about consciousness.
Yeah.
And how like you really think back and you can't really remember your first memory. Like, I think this might have been my first memory, but it's kind of blurry back then. So it's like, when did that actually really start? You don't really know. And like, do you remember what it felt like in the womb, or when does consciousness start? And it's kind of like, I think I've heard from people that like, just kind of is whatever. But I did think, and maybe that's me being silly, I think that the Big Bang referred to our solar system or galaxy only, not the entire start of the universe. And now knowing that it means the entire beginning of the universe, I feel like that's kind of silly. Who said that happened and that created the universe, and then, oh, because of this, that is how old it is. And it's like, what? I feel like...
This is a very interesting, when I was a kid, I was trying to make sense of I was a total nerd. I was trying to make sense of all this when I was like 12 or 13, and I found a book in the basement of our library in my hometown called The Big Bang Never Happened, which is a really interesting book. I recommend it. But yeah, it turns out that if you look back across history, people have thought, there's kind of a pendulum where people have this need for a creation of the universe, and people have this complete comfort in the idea that it's eternal, and that there is no beginning or end to existence itself. We seem to have passed recently through a phase where people need to feel reassured by the fact that there is a beginning. But the evidence is pretty screwy, and we'll deal with it next semester. And there's a huge conversation to be had there about what's going on, because there's only really 2 legs to the Big Bang hypothesis, and there's some problems with them, let's say. At the same time, it is still the standard model for cosmology. So, yes?
If there isn't a beginning, then how do you explain entropy?
Well, that might get beyond the scope of this class. What about entropy? Like, the entropy is weird because how do you explain life forms which are nightmares for entropy?
It's like those are the exception.
It's maybe the big, yeah.
Not exception, but you know, like there's bound to be some, you know, sometimes that it goes backwards.
Yeah, maybe there always is too. It's hard to say. I mean, I don't think there's a right answer. I can't advocate for one or the other, but you know, especially next semester, we'll have the luxury of time to really pick apart all these arguments and see. You guys can make up your own mind. Honestly, I don't know.
Back to like dating the universe.
Yes.
Possibility that if we're all like moving around one like center, maybe could they be looking past it and seeing further into the longer?
I'm not sure if I totally follow you, but they definitely think that the farthest things that they can see are at a light distance of this date that they put on the beginning of the universe. Yeah, I don't know. This is a huge part of our next semester's stuff. So it really requires to be let's say, responsible with this conversation. We have to really look at why people thought that, why there was this revolution in the early 20th century that people started to believe magically, like why they jumped on this idea. I will tell you that the Big Bang Theory was invented by a Jesuit priest who was also a mathematician, and that the Pope was very happy about it. Because it falls very nicely in line with the Christian tradition of the creation of everything and so forth, and that priest had to tell the Pope to stop because you're making me look bad, kind of thing. But it's a really wild story, and the sort of behind the scenes debate about it right now is really fascinating too. So we're actually doing a conference next summer in Portugal for my podcast, and we're going to have a bunch of people to come and fight about this. It's going to be really cool. So if anybody's in Portugal next summer, come check it out. Okay. So the moon is just one of these, and honestly, with each one of these things, we're going to see there's lots of theories about these things, all these bodies and where they came from. But again, I think the main takeaway here is if things are older than we presume them to be based on this radiometric dating, we have a lot more time to form things. In other words, I know I stopped last class and I was pointing out that there's basically when we're trying to say what the heck a moon is, part of it is that it's round. It's able to sustain this kind of round formation because it has enough mass, to collapse itself in all directions so it doesn't deform, right? Because if you just have a small blob, it doesn't get rounded. But that doesn't really work out because there's bodies that are rounded in the asteroid belt that are way too small to have rounded themselves by gravity alone. So then you got to start asking yourself, how did they get round? Well, the only thing I can think of is that they used to be a lot bigger, probably, right? So there's some sort of metamorphosis of these objects across time. How much time? Maybe a lot of time. Maybe a lot more than we are accounting for right now. Just to give you guys another sense of how much this stuff changes in very little time, back as early as the 1920s, the astronomers thought that the entire universe was the size of the Milky Way galaxy. Now we know there's trillions of galaxies spaced out by unimaginable distances from one another, right? So that's how much things have changed in 100 years, right? That the universe has gone from this big to this big, right? So the fact that these things would change radically would not be surprising to me, and that 100 years from now people have a very different date line for the universe, and they may be willing to entertain very different ideas of how maybe the moon didn't always look like that, wherever it is up in the sky. Maybe it used to look a lot more like a different kind of planet, for instance. I don't know. All right, so we got to talk about a couple more things. So there's a couple of, I'm working towards talking about eclipses here. In order to understand eclipses, you got to understand the moon's orbit is not perfect. So as it moves, it traces out a slightly different path each time. There's a couple of different pieces to this. There's one part of its wobble, let's say the orbit's wobble. It's called the apsidal precession, which is the one that we're looking at now. This is kind of the idea that the long part of its elliptical orbit is precessing, it's moving a little bit throughout time. There's another type of precession too, which is kind of the vertical wobble as well. So it's tracing out a slightly different vertical path as it goes. And the result of this is that we get the phases of the moon because it's not directly in front of the sun all of the time, right? So this stuff, you guys probably read about it in your textbook if you haven't already understood this, but it's kind of cool when you look up at the moon, the reason that it has all these different shapes has really to do with your perspective looking at it as the sun's hitting it. Half the moon is always lit, right? It's just a matter of where you are with respect to that moon as it goes around. So, and of course the rising of the moon changes depending on the season, right? Depending on where you're at, which makes sense. Now, that's going to lead us up. I'm not quite ready to go here yet, but this is going to lead us to the point that every once in a while, because of those different precessions of the moon's orbit, it gets in the way of the sun, which is really cool because then we have an eclipse, right? And those turn out to be quite predictable. They happen in pairs usually because that orbit is perfectly aligned, and so you usually get a few of them. Okay, but before we get to that, I want to talk about tides, because tides are pretty bizarre. In particular, so obviously the moon has some pull to it, right? It's made out of atoms. All atoms pull on each other. It's actually made out of quite a few atoms. It turns out that actually the ratio of our moon, the size of our moon to our planet, is really unusual. There's no other planets in the solar system that have such an enormous moon compared to their own size. So we see pretty big moons that are, some of them are bigger than this, but they're around planets that are like way, way bigger than us, like mainly the gas giants. So it's pretty big, which means it has appreciable effect on us here, and particularly our water systems. So this is interesting. In fact, it actually pulls on the rock part of it too, to the tune of like 20 centimeters in the direction of the moon as it goes. So, people started thinking about the moon being responsible for the tides all the way back in Galileo's day. Galileo actually hated the idea because he couldn't stomach the idea that there was some sort of mysterious forces that did stuff, which I think is really interesting. He was like, well, how would that happen? And nobody knew. They didn't really have gravity worked out as a concept yet. And even gravity is kind of kicking the can down the field, yeah, so to speak. So this is the story. This is kind of the simplified one you'll see in the textbook. It's a little bit more crazy than this, unfortunately, because of the fact that there's ocean currents, the moon, there's terrain, right? There's little bays. It's actually very difficult to predict the tide based on just the position of the moon. There's also this fact that, let me see if I have a picture of this. Yeah, I do. So there's actually this interesting effect too, which is that the tide itself sort of precedes the moon's position, which is kind of difficult to wrap your head around, except for you can think that the Earth itself is spinning faster than the moon, right? We spin past the moon every night, and it's in a slightly different position each night. But as we spin, we're kind of dragging that water with us. So the actual bulge, if there was one, even though it's a bit chaotic, like I showed you in this picture, the bulge precedes the moon. It's in front of it, which is very, very bizarre. But it makes sense if you really think about it. Then we have this idea of big tides too. So sometimes the sun and the moon are aligned with the ocean, and you actually get an even bigger tide. This is called a king tide. And then you can get one where the moon's at 90 degrees, and you get a smaller one called a neap tide. It's kind of cool. I don't know why I put this slide in here, but I think I want to point it out to you guys anyways. It made sense to me last year, I guess. There's a lot of water in the Earth that isn't in the ocean. You guys know about this? Pretty bizarre. Something like 6 times the Earth's ocean is under our feet, and it's not in the form of liquid water necessarily. It's in the form of hydrated minerals. So water molecules all clustered around these little rock ions, basically. So this is all really interesting when you start talking. This is more for when we start talking about the formation of the oceans. But when I was a kid, you ask people, the scientists or the textbooks or whatever, you say, where do the oceans come from? And they say, well, there's a period in the Earth's formation where it was getting smashed by these icy comets all the time. And I remember being like 10 years old, being like, that's a lot of comets. Like, have you been to the ocean before? That's crazy. I don't think people really buy that so much anymore. I haven't looked at Wikipedia about this recently, but it seems like people are more and more open to the idea that chemical reactions actually produced all those oceans. Tons of chemical reactions produce water. It's a very common element throughout the cosmos. Yes, please.
I don't know where I heard this, but I guess I'm not sure if there's water outside of the Earth. Like, is there water on other planets?
Oh my God, yeah, so much. an unbelievable amount. It's very common. There's clouds of water out there that are like light years across. I mean, there's, so NASA just launched this little spaceship that's going to go out and check out one of the moons of Jupiter. It's called, I think it's called the Europa Clipper mission. And they harbor deep suspicions that there's a huge ocean beneath this icy shell on this moon that's perhaps, 100 kilometers deep. Huge ocean. And so all of the origins of life people and the biologists are super excited because they think they might find some little green bugs down there.
So does that kind of get into a little bit of the conspiracy that I'm talking about? When you have water hundreds of kilometers under the earth, where there's water, there's life. So are there somehow ancient civilizations under our
I haven't seen any. Yeah. There is a really interesting, there's this guy named Thomas Gould, who's like one of these awesome polymaths from the 70s, who wrote a lot about the deep hot biosphere. So they actually, everywhere that humans have been, we've dug mines like 5 miles into the, I don't know what the deepest hole is, I think it's in Russia. Everywhere we've ever been, we've found life forms, living in incredibly inhospitable conditions, like unimaginable prior to going there, where people are just like, what? How's that possible? They don't need oxygen. They eat, methanes and stuff, right, that's down there. By the way, when I was a kid, there's another paradigm. They used to call oil fossil fuels when I was a kid, right? Well, they find them way beneath where any animals ever lived, or any plants, I should say. So that's no longer a thing. There's lots of abiotic generation processes for oil. And the bacteria eat it. They eat rocks. They'll eat anything. There is stuff down there, and it's weird. And a lot of the, my wife will talk about this when she comes and talks to you guys about origins of life, but there's people who are very, they're always looking for where did life start? And so there's a camp that firmly believes that it started deep, deep underground, actually, as a result of some of these discoveries and other factors. So little green men underneath, living in the hollow earth, I don't know about that one, but I'll believe it when I see it. But there's definitely life forms of some sort. Yeah.
Going back to the formation of oceans, I was just thinking of like the molten core and everything that we looked at earlier. One product of every most combustion reactions is water.
Yes, right. And many, 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 many other chemical reactions. Naturally, yeah. Yeah, the formation of the Earth, like we'll talk about it some more, but that's just like the formation of the moon. That one is fiercely constrained by the radiometric dating, which limits the timeline by which you can have a lot of processes happen. So our possibility space is constrained, perhaps unnecessarily. But there's really interesting theories all the time. There's one in a very prominent journal, in the journal Nature, a couple of years ago, where people were talking about the Earth being having this enormous atmosphere originally. And the atmosphere was largely hydrogen-rich. And of course, there was oxygen present as well, in the form of different silicon, like sand, basically, which has a ton of oxygen in it. And the reactions, essentially, as it cooled, it created lots of water in the process, amongst other things. So there's plenty of ways to get liquid water. Any trip to a chemistry lab will teach you that. Almost every reaction makes water in some form, yeah.
I don't really understand gas giants. Do they have like an inner core like the Earth has? Like they have the metal core?
Yeah, that's a fun story. We'll do plenty of time on gas giants, and we will talk about that. It has really interesting implications for the sun, too. So they think that they're hydrogen still. They may have, they're different, so there's different gas giants. But the ones like Jupiter is a quintessential gas giant. They think it has something like a liquid metallic hydrogen core, because it turns out that in the last few decades, people realized that if you put hydrogen under enough pressure, it starts to act like a metal, actually, like a liquid metal. This has interesting implications for the sun, because the sun is obviously under similar pressures. And the sun is considered to be something without form right now, and that's perhaps leads to a lot of confusion. But we do that next semester. We don't have time for the stars, unfortunately. Yes?
What about like the surface of Jupiter, if it was at all possible to get to Jupiter, like, could somebody step on the surface, or would they be sucked into like a solid part of it, or?
Yeah, so phases start to fall apart under these kind of pressure conditions, right? It's like it's not the simple solid liquid gas situation that we're used to. It's some mashup of those. The gravity is extraordinary. It would suck you down. You would probably get crushed inside of the liquidous, it's a hydrogen, but it's so dense that we wouldn't really think of it as a gas. It would hurt. Yeah, it would not be good. There's no real surface, though, from what we can tell. There's no place. There's nothing you could stand on. Yeah, but we'll do Jupiter. We're gonna do all of those. We'll give. Yeah, as long as we don't keep talking about highways and trains, we'll get there eventually. Okay, let's keep cruising here. All right, so I want to start talking about eclipses next, but before I do that, I am going to point out one more interesting thing to you, which is that the actual friction of the tides does, in some sense, cause everybody to change their speeds a little bit. So it causes the Earth to slow down to have that moon dragging across it all the time. But because that angular momentum is conserved, the moon's kind of slowly working its way outwards. This is kind of the thing like the figure skater who's spinning, right? As they stick their arms out, they slow down, right? Likewise, if you slow down, your arms will go out to the side. So this is happening. There's this feedback mechanism, and the result of that is that the moon is leaving, sadly, very slowly, something like 3.8 centimeters per year, which is quite interesting. Will it be a problem when it's gone? I don't know, but that's going to take billions and billions of years to happen, so we'll probably have everything worked out by then.
How does that affect time?
Like the measure of time, like the day and all of these things? Yeah, it's interesting. Actually, the year seems to have been shorter in the past, particularly millions of years in the past. Time is kept like by atomic clocks right now, which unfortunately are subject to gravity as well, it seems. So yeah, keeping a standard like that is very, very tricky. So yeah, I assume it will affect the clock of the day at least. As long as the Earth doesn't lose an appreciable amount of matter, it shouldn't affect the atomic clocks. But the Earth is losing tons of material every day, so that's probably going to affect the atomic clocks too. Yeah, measuring times is very tricky. It's a real difficulty. Okay, so let's talk a little bit about eclipses. So we have two kinds of eclipses. We got the solar eclipse and the lunar eclipse. The lunar eclipse, anybody seen one of these? It looks like this. It's not quite as cool as the solar eclipse, but this is essentially when the Earth gets in the way of the path of the sun that's illuminating the moon. Now, you have the opposite thing that when the moon gets in the way of the sun, you have a solar eclipse. Let's see here. So these things, what do I want to say about them? I think the most interesting thing about eclipses is actually historical in nature. So, eclipses have typically been a pretty bad omen for a lot of different societies across time, from what I can tell. They've also been used to great effect to coerce populations into believing that you have a direct line of communication with the gods. So I think I touched on this with the Sumerians a little bit, and the Chaldeans, who were their astronomer class. It seemed like that knowledge was in some ways weaponized. So have you guys heard the Christopher Columbus lunar eclipse story already? No? All right, let's tell that one, and then we can wind it down, and we'll pick up with light next time. So, Columbus had this really interesting experience. I think when he showed up, he was, I think, on the island of Haiti, which was called Hispaniola at the time. I guess it's Haiti and Dominican Republic, right? It's one big island. Anyways, he was there. For whatever reason, he managed to impress the indigenous populations there, I guess with their big ships or whatever. They're actually really tiny ships, but somehow with their with their medals and everything, the indigenous people gave them a lot of hospitality. It may have just been their culture to provide hospitality to people too. But he kind of wore out his welcome because he started impressing a lot of these indigenous people into slavery and trying to get them to mine gold. They were like, why do you want gold so bad? You guys are weird. It turns out he wanted gold because they needed gold to pay their military debts because they were fighting these holy wars back in the Middle East, which is really interesting because we're still fighting wars in the Middle East. But anyways, he needed gold. He was enslaving all of these people. And at some point, they were like, not very happy about this. Now, they outnumbered him significantly. And so there was some real threats of rebellion at some point. So the tale goes that, Columbus had on board his ship an almanac that had astronomical tables that covered essentially the last, 100 years or so. And he knew that there was an eclipse coming. It was actually a lunar eclipse. And so he made a deal, he made a meeting with the local chieftain, and he told him that that their god was essentially unhappy with the way that his people were starting to treat Columbus and his men, and that he would prove it because he had this conversation with their god, and the god told him that he was going to blot out the moon the next night. And the trick worked, as the legend goes, in any case. And so, I don't know, I think that's in some ways quintessential for the way that these things have gone in the past for people. I think that these astronomical revelations are often used to cajole populations into obedience to some extent. It seems, that there was similar sorts of things going on, like the Aztec people were very, very concerned with the eclipses, and actually they were also equally capable of predicting them. They kept very good equivalents of almanacs. And they would essentially, all of the people would come together during these eclipses and try to chant until they would sing, essentially, because they had to sing in order to bring the sun back. Otherwise, it wouldn't come back. Which is really interesting because it's almost like this participatory experience where you're somehow involved in the outcome of the cosmos, which is just so very different from the way that we think about it today. So anyways, I held you guys over last time. Let's let you go a couple minutes early. Next time, we will talk about light itself, which is going to be very exciting, I promise. Have a great weekend, though, guys. It was really fun to talk to you.